A population P obeys a logistic model. It satisfies the equation. Boom. Okay, then it says the population is increasing when P is between what two numbers? You can see the answers are there. Population is decreasing when? Well, so if you look at this equation, this is the dp dt. So that's the change in population over time, right? That's the change in population over time. So when is that positive? Well, you can tell if you put a number in for P here that's between 0 and 11. How did I get 0 and 11 here? Because if you put in like 7, that's going to be 11 minus 7. It's going to be positive 4. It's going to be positive. So that'll mean it's increasing because the change in population over time is positive. And right, and you know, you'd also put a 7 in here, and it's obviously positive. But if you put anything bigger than 11, like you put like 12 in, then that's and put 12 in here also. You know, P's only one thing at a time. Put in 12, it's negative. This is going to be negative 1 times whatever this, 6 times 12 over 1100 is. It's going to be negative. So the change in population is going to be negative. It's going to be decreasing when P is greater than 11. You see, because 11 is the carrying capacity. That's what it is. In fact, another way you can see that, and we're going to definitely need for part C, is let's go up to here's the formulas from the class notes. And I'm going to grab this one because it has all the stuff. I mean, it's really in this one form, but I think we can transform it to this. It'd be easier for you. So look at this form right here. This has a 1, right? So a lot of times in math and science, they'll give us a formula, and we need to take our formula and make it look like their formula so that we can use the information they give us. I call it plastic surgery. We're removing the wrinkles, giving it a new look, but it's the same person. So I've got to take this formula here and make it look like this formula there so then I can identify the P0, the K, the R, the solution, and do what I need to do. Well, how do you make this look like this? Well, you got to have a 1, right? We don't have a 1. So, well, how do you get to do a 1? Well, you're going to have to take that 11 and I'm going to divide through by 11. That'll make that 1 minus, how do they do it? They do P over K. Yeah, 1 minus P over 11. Now, you can see you can't just take a formula and divide by 11, right? So you have to also multiply by 11. Do you see how I took this whole equation and I divided by 11 and multiplied by 11? So overall, I didn't change anything. That's what I mean by plastic surgery. It looks different, but it's the same value. You know, if I take a number like 3 and I go times 11, 33, and then I divide by 11, it's back to 3 again, isn't it? Right? If you take any number and you multiply by 11 and divide by 11, you haven't really changed it. Well, I took this whole expression, let me show you, and I multiplied by 11 and divided by 11. I let that 11 distribute in there, is what I did. Right? Now, why am I doing that? Because I want to give it a new look. It's got to have a 1. That's what would produce a 1 there. Okay, now what is this? 6 times 11? The 66 over 1100, like that. And so there it is. There's the new look. And now it has the look we need. It means it's got to have a 1 in front, like our formula, right? Here's our formula that they gave us right here. So RP 1 minus P over K. RP 1 minus P over K. So we got to have RP 1 minus P over K, dp dt. That's what the formula says. So now we go, oh, okay, now we got it. So we can say the 66 over 1100, that's R. The K, that's 11. Right. And what is the K? It's the carrying capacity. It's how much that environment can handle as far as limited resources, right? A population of fish or deer or whatever, there's a bacteria in a dish. There's just a limited amount of food and resources, space, things like that, that the environment can handle. It's called the carrying capacity. So whenever you go above that, so that's why it says above 11, you're going to have a decreasing population, get too many whatevers. But as long as you're between 0 and 11, you're going to be okay. That's why it says between 0 and 11, you're going to be increasing population until you hit that carrying capacity. Okay, let's use this information now to come down here and answer. Assume that P of 0 is 2. P of 0 is 2. Find P of 77. So I'm going to use this is the solution. Once we have it in this form, then we can use this solution. So the solution is KP0. So let me write that down. So it's already forgot it. P of t. This, as it says, this is the solution. Okay, P0. That's the solution. KP0 over P0 plus K minus P0. E to the what? Minus RT. So there's the solution. And it's telling us P of 0 is 2. So that means this is 2, this is 2, this is 2. Or no, the carrying capacity is 11. So this is 11, this is 11. The rate is this right here. The rate is 66 over 1100, which actually we can reduce that by 11, top and bottom. That'll be 6 over 100. Isn't that just 0.06? Did I that right? Yeah, 0.06. Ours is 0.06. All right. So we've about got it here. So the solution is we got 11 times 2 on the top, 22. P0 is 2 plus 11 minus 2, which would be 9. E to the minus 0.06 t, because ours is 0.06. So there's our solution. And they're saying find P of 77. It's like, oh, okay. Want me to just plug in 77 for T? Put in right there. 77 for T and hit the buttons on Desmos. So let's go do it. So I'll write it down. So it's 22 over 2 plus 9 e to the minus 0.06 times 77. Let's go to it. Let's go to Desmos. And I will go here and put in a fraction. It was 22 over 2 plus 9. And then we need an e function, huh? E to the power. E to the power, what? Minus 0.0677. So I think we need parentheses here. Minus 0.06 times, oh, didn't do that right, did I? Times 77. There we go, 10.53299. And we got it, 10.53299. So that's how we do it. So one more time, when they give us this equation, we have to give it plastic surgery, give it a new look without changing the value. So I both multiply by 11 and divide by 11. So I'm not changing anything. That makes it have a 1 here, which is the look we need to match the formula form. So you get a 1 here. Then you can say, okay, now I can tell what R is on the outside. I can tell what K is right here. So I knew what they were. They tell me P0 is 2, so I got P0K, P0, P0K. I knew what R was, right? I reduced it, 0.06. You could just divide on Desmos, right? And you do all that by hand work. Then plug in the 77, and we got it. That's how we work with the logistic equation.